Hello and welcome back. Today we're doing home lesson 1.2, so it's the second lesson of populations and resources. So remember in our last lesson we stated that the chapter 1 question will be what caused the size of the moon jelly population in Glacier Sea to increase. So as student ecologists, you are trying to investigate this question. We also, in the last lesson, learned a new key concept, and births and deaths happen in all populations. In Glacier Sea, the moon jellies have been observed being born and dying when they are eaten by predators. The observation is evidence of this key concept. Within a population, organisms are always being born and dying. Today we will begin investigating this first question. How do births and deaths in a population affect its size? We're going to use Google Slides to create a birth and death model. You'll investigate the effects of births and deaths on population size. We will look at an example of the birth and death model together. In this example, the yellow tokens represent the organisms. So we have these yellow tokens here. Each one is a single organism. For this model, you will have a population circle. Any organism in the circle represents an organism in the population. You'll add organisms to a circle to represent births and take them away to represent the deaths. So we'll put them in when organisms are being born, and we'll take them away when organisms are dying. You're going to complete 3 different missions today. Mission 1, make the population stay the same over time. Mission 2, make the population size increase over time. And mission 3, make the population decrease over time. So as you complete your missions, each year some organisms must die and some must be born every year. But you get to decide how many. You will choose between 1 and 3 births and 1 to 3 deaths per year. At the end of each round, you're going to record what happens in your data tables and your graphs. You will start the model with 14 organisms. So you'll put 14 tokens inside the circle. Let's say for the first round, you choose to have 3 births and 2 deaths. You'll add 3 items to the circle and take away 2. Add 3. Oh, we're putting our 14 in. Very good. On the table under year 1, you'll record the number of births and the number of deaths. Then you'll figure out the number of organisms you are left with at the end of the round. Since we started with 14, we had 3 births, but then 2 deaths. The number of organisms after year 1 would be 15. Finally, you'll need to graph your results. You'll make a dot showing the number of organisms for each year, and then connect the dots. We're now going to go to Google Classroom and open number 2 for today, which is the birth and death model. Read the directions on slide 1, then complete the 3 missions. Come back to these slides when you finish. So Google Classroom, number 2 for today. So if you need to pause the video while you get that opened up, please do so. Birth and death model. Births and deaths are always happening in a population. How does the number of births and deaths in a population affect its size? To find out, try these 3 missions. Mission 1, make the population size stay the same over time. Mission 2, make the population size increase over time. And mission 3, make the population size decrease over time. Step 1, add 14 circles or organisms to the gray circle on the birth and death model population cycle on the next slide. This is your starting population of 14 organisms. Every year, 1, 2, or 3 organisms must die, and 1, 2, or 3 organisms must be born. How many is up to you? To make an organism die, remove it from the population circle. This counts as one death. To make an organism be born, add one item to the population circle. Count this as one birth. At the end of every year, record the number of births, deaths, an organism in the population on the chart and plot the number of organisms on the graph on the following slides. Remember your mission. Repeat until you have modeled 6 years. At the end of 6 years, add up the total numbers of births and deaths and record it in the total column. Complete all 3 missions. All right, so let's go ahead and work together to get this first mission going. So we're going to add 14 yellow circles to the gray circle on the birth and death model. So slide 2, we're going to put 14 of these over here. 1, 2, 3. All right, there's my 14. On slide 3 is my first mission. So I need to make the population size stay the same over time. So I have 14. I need to think about how can I get the population size to stay the same over time. I'm going to do what they did in the slides that we were looking at. I'm going to have 3 organisms be born. And then I'm going to make 2 die. So that leaves me with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So on here, I had 3 births, 2 deaths, and I ended with 15. But my goal is to make the population size stay the same over time. And if I'm starting with 14, I want it to stay the same. So what do I need to do in order to make this number remain at 14? Well, I would have to have another organism die. So I'm going to change that to 3 and go back to my circle and remove 1 because I had another one die. So now I have 14. Oh my goodness. Okay, so I'm going to change that to this, to 14. So you want to make sure that you're keeping it the same. So this organism down here should all end up being 14. So you need to think about how many births and how many deaths you should have for each year. Remember, you can have anywhere from 1, 2, or 3. Okay? So now that I've recorded it, I want to plot my information on the graph. So the directions say to plot the number of organisms on the graph on the following slides. Drag and drop these dots on the graph, then connect the dots with a line. So I'm going to grab a dot and I'm going to place it on 14 as best as I can. It doesn't need to be perfect. Let's try to move it down a little bit. Oh, that's bugging me. Honestly, it doesn't need to be perfect. I'm being too particular. All right, there we go. So I have my first dot. So I want to repeat this for 6 years. I want to plot my data for 6 years, and then you'll take your line here and you'll connect them with a line. Okay? So go ahead and pause the video, do mission 1, and then come back here once you finish mission 1, and I'll work to start mission 2 with you. Okay, so hopefully for mission 1, you have 14 right across the bottom here, and you have plotted a straight line going across here. Mission 2, we want to make the population size increase over time. So again, you want to start with 14 organisms, And you want to try to think about what do you need to do in order to get more organisms each year. So we're starting with 14. We want that number to go up each year, okay? So you want to think about your births and your deaths and make sure this number is increasing each year. And then after you've done that, put your dots, connect them with a line. You can pause the video, do mission 2, and come on back. So for mission 2, and if you did it correctly, all the organisms are going up each year. So year 6, you should have a lot more than 14. And then you should have a line that shows an increase on the graph. For mission 3, this time we're going to make the population size decrease over time. So again, you're going to start with 14 organisms in your circle, and this time you're going to manipulate the births and the deaths, 1, 2, or 3 each year, but you want the population numbers to be going down each year. So when you're finished, these numbers should be all less than 14 and gradually going down, okay? You use the dots to plot your information on your graphs. You can pause the video and come back here once you finish mission 3. If you did mission 3 correctly, your organisms the numbers should be going down. So all less than 14 and gradually getting less and less and less. And so your line should be showing a downward trend. The line should be pointing downwards. All right, if you need to go back and make corrections to any 3 of those missions, please do so. So for the conclusion, we're going to click this link and complete the 3 multiple choice questions. Click next, then hand in. So you want to click the link. That's going to take us to Amplify. And scroll down. Oh, sorry. Scroll down. Answer these 3 questions. So when the population stays the same over time, the total number of births is greater than, or is less than the total number of deaths. And you can go back and look at your data tables if you need to. Same question for when the population size increases over time and then decreases over time. Once you finish the 3 questions, click number 2, and then you'll want to click this hand in down here at the bottom. Pause the video while you complete that, and then meet me back at the Google Slides, the original lesson 1.2. All right, so you should have turned in your models as well as your questions in Amplify. If you haven't turned in your slides, please pause the video, go to Google Classroom, and turn those slides in. So hopefully you've noticed that when the population stays the same, the number of births was the same as the number of deaths. So if you have just as many organisms being born as you do dying, then that population is going to stay constant or stay the same. The population increased when the number of births was greater than the number of deaths. So if you have more organisms being born than dying, then the population will go up. Population numbers will go down when the number of births were less than the number of deaths. So you have less organisms being born into the population than you do dying. That's going to cause your population to go down. Ecologists often use graphs to show data about populations. So just think for a moment, how were the graphs that you made different during the 3 missions? So you might want to go back and look at your slides and see how these graphs were different each time. How did the lines compare to one another? Please pause the video and think about that. So after looking at your graphs, hopefully you noticed that when the population stayed the same, the line was flat, right? It was constant. When the population increased, the line went up. And when the population decreased, your line should have went down. A population that is staying the same over time is an example of stability. Stability is when something stays mostly the same over time. It is stable. A population increasing or decreasing is an example of change, when something becomes different over time. So we had 1 year or one example where it was stable. That's when the population stayed the same. And then when the population was increasing and decreasing, that's what we call a change. That is the end of lesson 1.2. Thanks for watching, and I'll see you soon.